Okay, so we're going to go over the notes for speed, velocity, and acceleration. Oh my. So, what is speed? That's the first thing we're going to talk about. So, the definition for speed is that speed is the change in distance over time. And what this means is that when you're talking about speed, you have to measure two things: the distance an object travels and how long it took it to travel that distance. So the formula for speed is pretty obvious, that speed is equal to distance divided by time. A lot of times we shorthand formulas in science, so speed, we would say, is S equals D over T. Units are usually going to be in meters per second, but they're going to be interchangeable with whatever units you've measured your distance and time in. So, for example, in your car, you'll see a speedometer that measures miles per hour. But if you were in Europe, for example, it would be kilometers per hour. So it just depends on what you're measuring. In science class, we oftentimes measure distance in meters and time in seconds. So you'll have to keep track of what units you measured your distance and time in order to calculate the speed with the correct answer. And just like anything in science, when you do a calculation problem, your answer has to have units. So for example, 3 meters per second, not just 3, no naked numbers. So let's actually practice real quick. If you have a practice problem, number one says, so if I'm traveling in my car for 5 hours and travel a distance of 750 kilometers, what is my average speed? Notice I put in there average because speed can be calculated as average, and it can also be calculated instantaneously. So when a police officer is using a radar gun to find out how fast somebody is driving, that's instantaneous speed at that exact moment. But if I'm trying to figure out how fast I'm driving when I go from, let's say, Washington, D.C. to Florida on summer vacation, I'm going to see how many miles it was to get there and how many hours it took. But that's average. Sometimes I'm going faster than the average, sometimes I'm going slower than the average. So for our class, we calculate average speed. So you would just write down on a piece of paper, and we do the 3-step method. You'd write down the formula: speed equals distance divided by time. And then you'd substitute in with what you know. So we're looking for speed, so we'd substitute in 750 kilometers, and we would divide that by 5 hours. And then you just plug and chug. If you're good at math in your head, go for it. If not, punch it in the calculator. 750 divided by 5 equals 150. And whoops, there's a typo there. That should say km over hr, kilometers per hour. So let's look at another example, and this time I want you to try this one on your own. It says if a helicopter can travel 16 meters in 4 seconds, what is its speed? So again, you're going to start, just like we did in this first problem, by writing out the formula. Speed equals distance divided by time. Go ahead and use the shorthand. Then substitute. S equals, now put in 16 meters for your distance and 4 seconds for your time, and then plug and chug. And you should get an answer that looks like this: speed equals distance divided by time, which is 16 meters divided by 4 seconds, which is 4 meters per second. Easy enough. We'll do lots of practice with calculating speed. You'll see that on your quiz. This should be easy. Let's move on and talk about velocity. Velocity is a vector, and we'll talk a little bit about what that means, but in general, velocity is speed, but in a specific direction. So for example, if you have a car that's traveling 70 kilometers per hour, in order to talk about its velocity, we would say it's traveling 70 kilometers per hour north. I find Despicable Me had a little funny explanation here, so let's just take a quick look and listen to this.
Hey. I'm applying for a new villain loan. Go by the name of Vector. It's a mathematical term, a quantity represented by an arrow with both direction and magnitude. Vector! That's me, because I'm committing crimes with both direction and magnitude. Oh yeah!
Love that movie. So anyways, as you can see, velocity is a vector, and a vector is it's a mathematical computation talking about something that has both direction and magnitude. So the magnitude would be the 70 kilometers per hour. It would be our speed. And then the direction is just talking about which way is it going. So why do we care about velocity? Why does adding direction really make any difference? Well, it's important when you're talking about things that are moving in an ominous amount of space. So, for example, airplanes would be paying attention to their velocity more than their speed. Is it traveling 450 miles per hour north, south, east, west? They might even use a compass heading going exactly at 330 degrees. Same thing with helicopters. These would make differences for where they're going to end up. Whether people would look at a storm traveling at a certain velocity more than just how fast is it going, which direction is it going, where is that tornado going to be heading next. So those are just some reasons why we use velocity. And then lastly, those fun types of questions that they love to ask you on the standardized tests. For example, a train traveling 70 kilometers per hour north leaves the station at the same time as another train traveling 60 kilometers per hour south. How far apart will they be in 3 hours? That directional unit makes a difference, because if they're both traveling in the same direction, they'll be a smaller distance apart. If they're both traveling in the opposite direction, north versus south, they'll be a much further distance apart. So that's why in science we kind of tend to look at velocity. But velocity is calculated the same way, distance over time. Excuse me. And then we'll talk about acceleration. Acceleration's definition is pretty much just the rate at which velocity changes with time or over time. And you can actually have no acceleration. If velocity does not change, then there's no acceleration. So if you're in that airplane and it's traveling at a constant velocity of 450 miles per hour south, then you're not accelerating because you're not going any faster or slower. So this shows a velocity time graph that shows a constant acceleration, or I should say a zero acceleration, because it's not actually changing. The velocity is constant with the time. So there are 3 types of acceleration that you do need to be made aware of. And the first one we call positive acceleration. It's when an object's velocity increases. In other words, it speeds up. So a lot of people think of that's the main definition of acceleration. I was at the stoplight, the light turned green, I hit the gas and go, I'm accelerating. But there's also negative acceleration, which is when an object's velocity decreases or it slows down. Remember, the definition of acceleration is a change in velocity over time. So the change could be a decrease. So when you slam on your brakes in the car to slow down, or slam on the brakes on your bike, or when you're running and you get to the finish line so you start to slow down, you have negative acceleration, and it would actually be represented by a negative number. And then, of course, like we talked about before, you could have zero acceleration, which is when the velocity just doesn't change. So that could be you're standing still and not moving. You could have acceleration of 0. But you also could be in an airplane traveling 525 miles per hour, and you're obviously moving very quickly, but you could still have 0 acceleration if in 10 minutes' time the speed or the velocity has not changed at all. Then your acceleration is still 0. Excuse me again. So you need to know how to calculate, again, average acceleration. So here's the formula. You'll want to write that down. Average acceleration is actually equal to the final velocity minus the starting velocity, and then divided by the time to change that velocity. Or we give it the shorthand as A equals VF minus VI. VF meaning velocity final minus velocity initial, which is starting. And then divided by delta T. So that green triangle there, that's for the Greek symbol delta. And in science, we always say that delta means change in, so change in time. So, for example, what is the velocity? Actually, this should read, what is the acceleration? What is the acceleration of a car that starts at 0 meters per second and increases in velocity to 15 meters per second in 5 seconds of time. So on your note sheet, you have a little acceleration practice problem section at the bottom. So you go ahead and calculate that. Again, this is asking what is the velocity. So the car starts at 0 meters per second and increases in velocity to 15 meters per second, and it takes 5 seconds time. So let's actually try to look at that one together here. Imagine we have, okay, pardon the bad writing because I'm doing this on my computer. Acceleration equals VF minus, look at that, it won't even work, minus velocity initial divided by delta t. So we're going to plug in the numbers. VF was the second one, so it sped up to 15 meters per second. So we have 15 meters per second minus, well, we started at 0 meters per second. That was our initial. And this whole thing took 5 seconds of time. Now I'm being a bad teacher here, so let me go in and add in my units. Meters per second, meters per second. And then down here, this is just seconds, it's time, okay? So obviously we can do the math. 15 minus 0 is still 15. 15 divided by 3, or I'm sorry, by 5 equals 3. So 15 divided by 5 equals 3. But what are my units? I had meters per second on the top and then another unit of seconds on the bottom. So we would actually say meters per second, which we just say is meters per second squared. Okay, meters per second times second. So whenever we're talking about acceleration, the unit is going to be the unit of distance divided by the unit of time squared. It's a meters per second squared, or it could be miles per hour squared, because this is how fast it is going, meters per second, every second. So what we're saying is every second the speed increased by 3 meters per second. So 3 meters per second, 6 meters per second, 9 meters per second, 12 meters per second, and finally by the 5th seconds it was going 15 meters per second. And if it continued to accelerate at that same rate, then a second later it would be going 18 meters per second, 21 meters per second, 24, you get the idea. And so that's how you calculate acceleration. And that is your notes here on speed, velocity, and acceleration.